Hello friends, today I'm going to show you how to find operations of operations in polynomial function, their sum, their product, their difference, and their division, uh, their their quotient value. For today, we will see the first three operation: addition, subtraction, and multiplication. The first thing is first rearrange the function using their degree in terms of degree. uh, Therefore f of x, which is equals to x to the power of 5 from the largest degree, x to the power of 5 plus minus 2x to the power of 3, the second largest, and plus 3x squared minus 8x plus 1. G of x is equals to x squared plus 8x plus 8x plus 5 plus 5. Those two functions, both f of x and the g of x, we can find their sum and their product. First, f plus g at x, which equals their sum of the two. Therefore, we can, in arrow form, in column form, x to the power of 5, we can rewrite it in column form, x to the power of 5, the next is x to the power of 4 for our purpose, minus 2x cubed plus 3x squared minus 8x plus 1 and g of x in column form, second row, in front of x to the power of 5, 0 x to the power of 5 plus 0 x to the power of 4, because there is no expression with degree 4. Again 0 to the power of x to the power of cube plus 2x squared plus 8x plus 5. From this we can add those two functions with corresponding degree. The corresponding degree of x to the power of 5, its coefficient is 1. This one is 0. We can reject it because both are 0. The second one, minus 2x cubed, 3 plus 2, 5. Therefore, the coefficient of x squared is plus 5 plus 5 x squared minus 8 plus 8. Therefore, 0. The coefficient of x is 0. Therefore, we reject it, and the constant term is 1 plus 5 is 6. Therefore, the sum of the two functions becomes x squared minus 2x cubed plus 5x squared 6. This one is the sum of f of x and g of x. Similarly, we can subtract f minus g at x equals f of x minus g of x. Again, we can rewrite in column form for in understandable way. Therefore, x to the power of 5 plus again 0 to the power 0 x to the power of 4 minus 2x cubed plus 3x squared minus 8x plus 1. In second row, this one is 0, this one becomes 0, this one is 0, and this one is 2x squared plus 8x plus 8x plus 5. We can subtract in column form. Therefore, and this becomes x to the power of 5 plus this one is 0. We can reject. Therefore, minus 2 minus 2x cubed, 3 minus 2, since the operation is difference. Therefore, 3 minus 2, 1. That means plus x squared, 8x minus 8x. Therefore, minus 16x, because minus 8 minus 16x. 1 minus 5 minus 4. This is the difference of f of x and g of x, or f minus g at x becomes this one. The third operation is the third operation is multiplication. Therefore, we can multiply in column form. Therefore, the first one is 5. 5 plus 5. 5 times 1, 5. 5 times minus 8x minus 14x, 5 times 3x square, positive 15x square, 15x square, 5 times minus 2x cubed, 5 times minus, this one becomes the minus 10 x to the power of 4, x to the power of 3, because the degree is 3, and 5 times x to the power of 5, 5x to the power of 5. But between those terms, x to the power of 5 and minus 10 x to the power of 3, there is a coefficient 0, x to the power of 4. And the second one, 8x times 1, 8x plus 8x times minus 8x minus 16, 4x square. This one times this one, minus 64 x square. The next, 8x times 3x square means that 3 times 8, 24 x plus positive 24 x to the power of 3. This becomes, and the last is that 8x times x to the power of 8x times x to the power of 5. 8x, one operation minus 16x to the power of 4, because 8x times minus 2x minus 16x to the power of 4, and the last one is 8x times x to the power of 6. Therefore, we can rewrite in this form x 0 x to the power of 4, and in the second row 0 x to the power of 5. Since their coefficient is 0, therefore they are written in imaginary. And the last one, 8x times x to the power of 5, therefore 8x to the power of 6 plus the second term, the third term, 2x square, this becomes times 1, this is positive, therefore 2x square minus times minus 8x minus 16x cubed. The third, 2x square times 3x square, therefore 3 times 2, 6, positive 6x to the power 4. The next, 2x square times minus 2x to the power of 3, therefore minus 4x to the power of 5. Since x square times x to the power of 3, that means that x to the power of 3 plus 2, x to the power of 5, and 2x square 0 to the power of x, because the coefficient of x to the power of 6 is 0, therefore it remain unwritten, and the last one, 2x to the power of 7. 2x square times x to the power of 5 becomes 2x to the power of 7. This is individual multiplication of g of x with respect to f of x. Therefore, we can add with respect to their degree. Therefore, 5, this becomes 5 plus minus 14 plus 8x minus 32x, 5 is positive. The second one, the coefficient of x square, 15 minus 64 plus 2, therefore it becomes minus 47 x minus 47x square. The next one is x to the power of 3, therefore the coefficient of x to the power of 3, you can add those, minus 10 plus 24 minus 16, it becomes minus 10 minus 2x cubed. It becomes 0 to the power of x, this is hidden, therefore 0 minus 16 plus 6 are the coefficient of x to the power of 4, therefore their sum become minus 10 x to the power of 4. The last one, x to the power of 5, the coefficient of x to the power of 5 minus 4 is 1, therefore positive x to the power of 5. The coefficient of x to the power of 5 is 1, and x to the power of 6, that means 8x to the power of 6 plus this becomes 2x to the power of 7, 2x to the power of 7. The product of the two functions f of x and g of x, f of x, f g at x, or f of x times g of x becomes 2x to the power of 7 plus 8x to the power of 6 plus x to the power of 5 minus 10x to the power of 4 minus 2x cubed minus 47x squared minus 32x plus 5. This is the product of the two functions f, g at x. Generally, since the degree of f g at x is equals the sum of the two, degree of f plus degree of g, the degree of g of x. This becomes 5 plus 2, which equals 7. The degree of f g at x is 7. The degree of f is 5. The degree of g is 2. The degree of f plus g, or degree of f minus g, which is equal, both are equal. It equals the degree of the largest one, becomes the degree of the largest one. If the degree of f is greater than, therefore greater than g, the degree of f plus g or the degree of f minus g is equal to f. Whereas the degree of f is less than the degree of g, therefore